All right. So
before you kick off, I'm just going to say hello, everybody. This is the OLM Working Group meeting. Today is July 28th, 2022, and Joe will be leading a discussion on improving the local source type. Joe, do you want to share your screen, or do you want me to share my screen for this?
let's see. Actually, I'll just share my screen. I think I might have a demo I can do as part of this too.
Perfect.
Let me share. It says I can't share while you're sharing. Okay.
I've stopped sharing.
Okay, tell me if. Nope, don't want that to happen. I have to give approval. Let's see. No, it wants me to put it. All right, one sec. Let me try something else. Okay, you all see that?
Yep.
Okay, so first thing is basically, so we have this local source. The impetus behind it was basically like we have no way of kind of enabling a developer workflow or another workflow that needs to basically like inject bundle content into the cluster without having it in some remote repository somewhere. So the two obvious use cases for the local source are, you're implementing a bundle locally and you just want really quick iteration so that you can, make some changes, apply it, see what happens, make some more changes, apply it, see what happens without having to push a git commit or upload an image and build an image and upload and stuff like that. So that's kind of the use case behind the local source, but it has two limitations. So the first is that because it uses config maps, it has this etcd value size maximum that we've been talking about in all sorts of different areas of OLM. And it means that basically, like right now, the way that local source is implemented is you can't have a bundle that's larger than 1 or 2 megs, depending on how you do it, which is the same sort of problem that we've had before with unpacking bundles and stuff like that. The other problem is that the way it's implemented is it only supports plain manifest bundles because it expects a config map that has just like a single directory's contents in it. And other bundle types might have a different directory hierarchy that has more than one directory. So as I was working on a pretty similar source called the upload source, I was kind of looking at some other APIs for inspiration. And it turns out that the OpenShift build API has a very similar sort of sourcing mechanism that we do for bundles. And they have something that's kind of like our upload, which lets you just kind of send arbitrary tar-GZs into the bundle. But then it also has this type called config maps, plural. So that caught my eye. So I think what I would suggest is that we change local to be called config maps. And rather than having it support just a single config map, we can have an API that lets you basically say, like, for this directory, mount this config map. For this other directory, mount this config map. And you can even have multiple config maps per directory as long as none of the keys in those config maps overlap. So in that case, like now we've completely eliminated the problem with directory hierarchies, because now you can say like this config map goes in this directory. And we've significantly improved this problem because we can have basically the limitation changes from 1 megabyte plus or minus for the entire bundle to 1 megabyte plus or minus for each file in the bundle. So you can have an arbitrary sized bundle as long as every individual file in that bundle is less than a meg. So for most bundles, that probably works. Of course, you still have the problem of like, well, what about a CRD that's 5 meg? But that never works anyway, because you try to apply that CRD and the API server explodes because the CRD itself is too big. You might have other bundles that, like, for whatever reason, like, package some binary in them for some reason. And that could cause a problem potentially. In which case, like, we have the upload source that you could use. But for lots and lots of bundles, like if we switch to this config maps mechanism where you can mount multiple, then I think we like eliminate most of the problems with this source implementation as is. So before I think I can do a demo of this, but Alex kind of put me on the spot, so we'll see. I'd like to, so I'll try it. But before I do that, does anybody have any questions or anything? If not, let me see if I can share the right screen again. Take me a sec. All right, you all see a terminal?
Yep.
Yes.
Sweet. So let me back this out. I just created it. Cool. So what I have here is I have a memcached API directory that has a manifest directory in it. So I'll show you what that looks like. So there's just a single file, manifest.yaml. What I'm going to do is create a config map out of it. I'm going to put it in the Ruckback system namespace. And I'm going to make it immutable because some of the code that I wrote forces these things to be immutable, mainly for our bundle immutability promises. And then we apply this to the cluster. So let me do that. We've got a memcached manifest in there. So now if you look at this, I've got a bundle deployment. It's going to use the plain provisioner class and for both bundle and the bundle deployment, and I'm going to use this type config maps. And then I have the config maps. It's a list of these things, right? So you basically specify the path that's relative to the root of the bundle that you want to mount this in. So for plain manifest bundles, it expects a manifest directory at the bundle root. So that's why this is here. And then it asks you for the name of a config map that you want to mount at that location. So if we create that, first I'll show you, I don't have any bundle deployments. So now I've got one bundle deployment, the installation succeeded. If we go look at the bundle, then we've got it unpacked. It says it's type config maps. Uses our config map source, mounts it, and it's available at the normal place you would expect to be able to download a plain provisioner bundle. That's basically it. If you had different, if you had different bundle formats, like say you had a registry v1 bundle, that usually expects both manifest directory and a metadata directory. So in that case, you would just create another config map called like, v0.1.0 metadata. And in your bundle deployment template spec, you just have another one of these that said path metadata with memcached API v01 metadata. And then you'd end up with both of those things mounted such that by the time the bundle provisioner saw it, it would look like a normal, a normal registry v1 bundle. So that's it. There's a whole bunch of stuff that needs to probably still happen for this to become something that's mergeable. But proof of concept for the API, I think, is the point of this demo. Any questions on this piece or comments? All right, well, that's all I got.
Yeah, I think this is going to be very useful just for, allowing us to get around the config map limit size in a bundle. It's really nice.
There's the other kind of nuances here is because it's a config map that gets referenced, it's possible that the config map can change, right? So that's why I was saying earlier, like, okay, let's enforce in the unpacker that any config map that gets referenced is immutable. So that part's good. That way you can't just go and change a config map's contents. But that doesn't preclude deleting the config map and then creating a new one with the same name that has different content in it. So part of what we need to do, I think, is also add a webhook that watches config maps in the RUCPAC system namespace and says, if someone tries to delete a config map there, then let's go look at all the bundles and make sure that it's not referenced in a bundle. And if it's not, then let the deletion happen. If it is referenced in a bundle, then just block the deletion and say, like, sorry, like, you can't delete a config map that is referenced by a bundle. If you want to, like, go and delete the bundle and then delete the config map. That way you don't have a possibility of that bundle content changing when the bundle is live. And then the real worst part is like when the bundle deployment is running, because then it's like, well, what's the source of truth? Is it the old version that we originally sourced, or is it what's present on the cluster now? And it adds all of these potential areas of confusion. So I think we have a little bit more to do to make this something that is pretty robust.
Hey, Joe, I have a quick question for you. More of a thought experiment that I think what you just said answers. I think, unless I'm misunderstanding this whole system, that it's possible for two bundle deployments to reference the same config map if you set everything up in a certain way.
Yep.
Have we thought about that case? And if so, is that something we want to support, or is that something we want to try to block with that webhook you just mentioned?
I don't think we need to block it. Like, we've already got, you can already create two different bundle deployments that refer to the same image. And when that happens, whichever bundle deployment tries to reconcile second basically loses, and the bundle deployment, the provision, at least the plain provisioner, it basically says, like, hey, something else already controls this object that you think you own. So no, sorry, like, you can't. So I think in the case of config maps being shared, if that resulted in the provisioner trying to provision the same object, then you would run into a problem.
Okay,
So,
gotcha.
Yeah, so I think,
and like you were saying, as go ahead. Sorry, I think I'm
just gonna say, in my
talking
opinion,
over you.
It's totally fine in my mind for two bundles to refer to the same config map.
Cool. Yeah, that sounds right to me. And then also, the other question that I was going to have, which I think you answered before, was if we have two bundles that reference the same config map, then there will be a situation, and you'd like say you delete that config map, then we would have an issue there. But it sounds like with the webhook that you're talking about, there wouldn't be a big issue because we would block it if it's owned by something.
Yeah, the flip side. So yeah, I think that's another good reason to block it, right? Is like, well, if it's just gone, are we gonna are we gonna then try to re-unpack the bundle and say that the bundle is invalid? And then what's that mean for the bundle deployment? So I think just blocking the deletion just skirts around that whole problem. But you have the flip side of the problem, which is I create a bundle and the config map that I'm referencing just doesn't exist. But in my mind, that's fine, because we can just have the unpacker just say, like, okay, I'm still pending. I'm just waiting for that config map to exist. And then we would, when the config map shows up, we would reconcile and say, okay, now we've got everything. We can go ahead and start unpacking. So I think that problem is mostly solvable as well. Although I posted in the RUCPAC dev channel in the Kubernetes Slack that I was working on this multi-namespace cache thing, which is directly related to this config map thing, because what I think we want to do is say, we want to be able to watch config maps so that like when this when the bundle create happens before the config map create, we want to be able to see an event on the config map that says, hey, config map was created, map that over to the bundle that references it, and so we can reconcile it immediately. But to do that, we have a problem where in the bundle provisioner, or I'm sorry, in the plain provisioner, we're already potentially watching config maps cluster wide with a label selector that says like it has to be a config map with, owned by Ruckpack effectively. Whereas like one of these config maps might not have that label, and I don't think we should force it to because that's kind of weird. So I have this PR up in control runtime that basically allows you to say, for this namespace, use this cache implementation, which doesn't have a label selector for config maps. And for all other namespaces, use the Ruckpack label selector for config maps. That way, when we can just set up watches where we need to, and our cache will be populated with all the config maps from our own namespace, and then otherwise config maps that have a label from everywhere else. So I think that'll help solve that problem too. Hopefully that PR gets accepted. We'll see.
For sure.
Okay, Tim, I saw that you raised a comment. Do you want to discuss that?
No, I think we're good. And kind of loosely related stuff Joe and I were talking about last week around workload interrupts if you're deleting bundle deployments explicitly, but probably not worth talking about further.
Okay, is there anything anyone else wants to address before we conclude? All right, well, on that note, everybody, Joe, I'd like to thank you for giving that presentation, and we will meet next week for issue triage. Bye for now.